Hello viewers, welcome to this video. Right, in this video we will be looking at how to deploy Elastic Cloud in your Kubernetes cluster. So this is going to be a two-part series where in part 1 I'll be showing you how to deploy Elasticsearch and Kibana using Elastic Operator, right? And then in the follow-up video, in my next video, I will show you how to install FileBeat or MetricBeat to collect logs or metrics from your various containers in your Kubernetes cluster. So a few months ago, I did this video, Kube34 monitor Kubernetes logs using EFK stack, but I think this was based on Rancher. So in that video, I deployed Rancher to manage your Kubernetes cluster, and then we deployed Elasticsearch and Kibana from the Helm repository through Rancher. And then we deployed FluentBit to collect the logs from various containers running on different worker nodes in your Kubernetes cluster. So that was done 9 months ago. So Elasticsearch, elastic.co, Elastic company has released this Elastic Cloud on Kubernetes based on Elastic Operator, so which we will be looking at in this video. Okay, so I've got my notes here for this video. So the setup for this video is like, I've got my Kubernetes cluster, and this cluster, all the nodes in this cluster are running in LXC containers, and I'm using Kubernetes version 1.17 with one master node, 2 worker nodes. All of them are CentOS 7 Linux containers with 2 CPU and 4 gig of RAM. So that's important. So if you want to deploy Elasticsearch, the worker node should have at least 2 gig of memory just to deploy one Elasticsearch pod, because in the manifest we will be the manifest will have like CPU limits and the resource limits for memory. So unless you have 2 gig of free RAM available on any of your worker nodes, you won't be able to install Elasticsearch. So that's the requirement. For that, I've got my K8s profile, LXC profile, which allows me which allows all these containers to use up to 4 gig of my RAM from my host machine. And I've also got NFS server running, and I've done a separate video on dynamic volume provisioning long time ago. So I'm using that in this video for dynamic volume provisioning. So the Elasticsearch cluster that we are going to deploy will need persistent volume. So for that, I've deployed the dynamic volume provisioning, and my host machine is actually not Manjaro Linux. I've switched to Ubuntu 1904, but it's on the same laptop with 8 CPU and 16 gig of RAM, and the kernel I'm using is 5.3, not 5.4. And I'll also be using Container Lens. The previous video I did was about this Container Lens, which is a beautiful dashboard to view your clusters. You can add as many clusters as you want in your Kubernetes, in your Container Lens dashboard, but unfortunately they are closing their business and this product is no longer available. But since I registered with them before they closed their business, I still have access to my Container Lens account. So it's here, Container Lens. I can view the nodes, I can view the clusters. So it's not a requirement, it's just easy for me to grab certain information from the lens instead of running the kubectl command, but I will show you both the ways for those who haven't got Container Lens. Okay, so let's go back to our node. So that's my current setup, and okay, so and the thing we will be doing in this video is this one, Elastic Cloud on Kubernetes. So Elastic Cloud version 1.0 is generally available now, GA version, and it's all based on the Elastic Operator. First, we will be deploying Elastic Operator in our cluster, and that's going to deploy custom resource definitions like Elasticsearch, Kibana, APM server for application performance monitoring. So using that Elastic Operator, we can deploy Elasticsearch, Kibana, and so on. All right. So it's going to just deploy 3 custom resource definitions, and you don't have to use Helm or anything to deploy Elasticsearch cluster, Kibana, or anything. So we will be using Elastic Operator, and then Elasticsearch, Kibana, APM server will all be resources like any other Kubernetes resource. So you can, for example, pod, daemon set, deployment, replica set, config map, secrets. So similar to those resources, you can deploy Elasticsearch Kibana as a resource. So Kubernetes will identify them as a resource using these custom resource definitions. And as you know, Elasticsearch will be listening on port 9200 and Cabana on 5601. And Elasticsearch will be deployed as a stateful set because it has to be in a cluster format. But for this video, I'll be following their documentation where we will be deploying just one Elasticsearch node in the cluster and one Kibana replica. Alright, so that will be Kibana will be a deployment with one replica. Elasticsearch will be a stateful set with one replica, and all these are signed by self-signed certificates, and the connection between Elasticsearch Kibana and whatever client you're using like Filebeat, MetricBeat or anything connecting to Elasticsearch, everything is TLS SSL encrypted. So you will be accessing using HTTPS using self-signed certificates. Alright, so in this video we'll be looking at this part here. And in the next video, I will look at either Filebeat or MetricBeat. So probably I will go with Filebeat because most probably you would want to look at the logs of all your containers in your Kubernetes cluster in one place. So we will go with Filebeat in the next video. All right. So now let me show you my Kubernetes cluster kubectl version -- short. So my client version and server version are 1.17.2. kubectl get nodes. I don't know why it's showing 1.17.1, but it's actually 1.17.2, and these are all running in LXC containers. If I do LXC list, you can see kmaster, kworker1 and kworker2. Okay, so that's my setup, and I've also got the dynamic volume provisioning setup and the metal LB for load balancing setup. Those are all not requirements if you want to just try it out, but I will show you different options you can use. kubectl get namespace. I've deployed the dynamic volume provisioning, metal LB, everything in a separate namespace called operations. kubectl -n operations get all. And you can see this NFS client provisioner, that's for dynamic volume provisioning, and I've also got the controller speaker, that's all related to metal LB. Okay, so that's my setup for this video. Let's dive in. Okay, I'm gonna go to the web browser. I'm searching for Elastic Cloud in Kubernetes. Okay, so Elastic Cloud on Kubernetes 1.0 generally available. So that's the documentation we're going to be following, the Quickstart guide. I'll put a link to this page in the description so that you can watch it. So the first thing we'll be doing is, if you look at the requirements, the supported version, or if you've got a Kubernetes cluster, anything above 1.12 version, it should work. And the supported Elastic Stack versions are 6.8, any minor versions of that, and 7.1 and above. All right. Okay, so let's do this. The first thing we are going to do is deploy the Elasticsearch operator. So we're going to deploy this component, which will deploy all these custom resource definitions. Okay, I'm going to copy this command here and paste it in my terminal. Okay, so as you can see here, custom resource definitions, there are 3 custom resource definitions it has deployed: APM server, Elasticsearch, Kibana, and it has created a new namespace called Elastic System. Let's take a look at that. kubectl get namespace, and you have this Elastic System namespace. kubectl -n Elastic System get all. Okay, the Elastic operator container is getting created. So once that's done, we can see kubectl get CRDs. Yep, it's already there. So that has deployed the custom resource definition, APM server, Elasticsearch, and Kibana. So we can do like what you do for kubectl get pods or any resources. Now we can do kubectl get Kibana, no resource, kubectl get Elasticsearch, kubectl get APM server. So these are all now valid Kubernetes resource that you can deploy using the Elasticsearch operator. Okay, let's take a look whether it has completed creating the container. kubectl get all, so not in that default namespace, it will be in the Elastic System namespace. Okay, so that's running fine. So the Elastic operator has been deployed and we've got the required custom resource definitions. And now we are going to deploy the Elasticsearch. So that's the manifest here. It's a simple manifest. You can customize it. API version is Elasticsearch. Kind is Elasticsearch, like pod deployment replica set. So this kind is, we are deploying a resource of kind Elasticsearch. The name of the cluster we are going to deploy is Quickstart. The version of Elasticsearch we are deploying is 7.5.2. Node set, and we are deploying just one node. All right. So node.master, so this is going to be the master node, and then later we can see if we can increase the number of nodes in this Elasticsearch cluster. Hopefully we won't be able to do it because I don't have enough resources. I haven't assigned enough resources in my Kubernetes cluster for that. Okay, so let's copy that. Copy and paste it. Okay, kubectl get all. Alright, so pod Quickstart ES default, that's pending. Kubectl get all, and now it's initializing. So it has got two containers. One is the init container, and it's now doing the init container at the moment, and then it will run the actual container. Okay, so now if you take a look here, the Elasticsearch we've deployed is a stateful set. All right, so here you can see two new services got created. And because this is a stateful set, if you followed my stateful set video, I would have explained about the headless service. So this service here is the headless service because the cluster IP is none. So this service, we won't be able to access Elasticsearch using this service because that's a headless service that's used by the members of this stateful set. At the moment, we've got just one member, one replica. But if we manage to increase the number of replicas in the stateful set, the replicas in the stateful set will be using this headless service to communicate with each other. And then this is the actual service that we will be using to access the Elasticsearch. Okay. Now let's take a look. Okay, it's still initializing. 78 seconds. Let's give it a few more minutes. Few more seconds. kubectl get all. Okay. And if I look in here, workload overview, and there's one that's pending, pods, daemon sets, and if I choose default, so we have the this namespace, sorry, the stateful set, and the pod, and the pod is initializing. Okay, so let's wait. kubectl get all, watch -x kubectl get all. Okay, so I'm going to pause the video. It only takes like couple of minutes to initialize the Elasticsearch container. Let's wait for it. Alright, so the pod is now running. So now, how do we access this Elasticsearch? We don't need to access the Elasticsearch because the way we will be accessing Elasticsearch is through Cabana. Cabana is used to visualize the data that's in the Elasticsearch. So the next video we will be installing FileBeat to send some data, send some logs from all the containers to the Elasticsearch, and then we can use Cabana to query the Elasticsearch and visualize the data. But for now, it's always a good practice to see whether your Elasticsearch is up and running. All right. So if I do kubectl get service, we have these two services. That's the headless service. We will be accessing using this service now. So we don't actually need to expose this service outside the cluster because the FileBeat that we are going to deploy in the next video will be inside the cluster. So the FileBeat deployment will be able to access this Elasticsearch cluster. So quickly, if we want to test it quickly, we can do kubectl port forwarding and then see if Elasticsearch is running fine. If Elasticsearch is looking happy, then we can move on to deploying the Cabana. All right. So as I told you, all these containers, all these connections between the Elasticsearch, Cabana, if you want to connect to Elasticsearch, are the connections between Elasticsearch, Cabana, and the clients to the Elasticsearch. Everything is encrypted using self-signed certificates. They are protected by authentication. So there's this default user called Elastic user. Elastic, so that's the username, and we need to find the password for that username. So what I can do is I'll show you how to grab that from container lens, but most of you won't have access to the container lens dashboard. Okay, so if I go to configuration, secrets, so this secret here, Quickstart ES Elastic user, so that's the secret that contains the password for the Elastic user. If I click on that, so that's the encrypted password, and if I click on this icon here, so WDP5RZ, so that's the password. And if you want to access it from the kubectl command, there is this command here. Okay, let's go to the terminal, kubectl get secrets, and we have it here, kubectl ES Elastic user. If I copy that, kubectl describe secret Elastic user data, and it contains the Elastic field. So we need to take that field, we need to decode it. It's in the encoded, it's stored in the encoded encrypted format. We need to decode it, and if you look in the documentation, they would have given you the command to do that. Yep, that's it. So let's copy that, copy and paste it. So basically kubectl get secret, and the same secret that I used, Quickstart ES Elastic user, and we are just getting the .data elastic, which is here, data elastic, and we're using base64 option, base64 command to decode. Okay, so now if I do echo $password WDP5RZ, so that's the same that we saw here, Elastic user, so that's the same password here. Okay, so let's copy that password. I've copied that. So now we can use port forwarding to access the Elasticsearch cluster to see if it's running fine. Kubectl get service, so that's the service. Copy kubectl port forward service, and we're gonna forward the port 9200 9200. Okay, so now we should be able to access it from our machine. Localhost :9200 Okay, your connection is not private. Advanced. Proceed to localhost. Make sure to use HTTPS. So I've used HTTPS here. If you use HTTP, it would have compliant, but now I think it has actually redirected me. I didn't specify HTTPS, but it redirected me to the HTTPS site. If you find any problem accessing the HTTP, yep, you would find this. If you use HTTP, then you will find this page. Make sure to use the HTTPS protocol and accept the certificate, because it's a self-signed certificate. Okay, so it's asking for the username and password. Username is Elastic, and the password is what we copied from the terminal. Sign in. Nope. Elastic. I must have copied the wrong password. Okay. Copy. Paste it. Okay, so if you see this, it's all working fine. So we've accessed the Elasticsearch, and it's returning some data here, JSON response. The version is 7.5.2. Name of the cluster is Quickstart. So everything is fine. Okay, so we verified that our Elasticsearch is running fine. And you can also check this, kubectl get Elasticsearch. Yep, Quickstart Elasticsearch health is green, face ready, version 7.5.2. kubectl get Kibana. So we haven't deployed Cabana yet, so that's what we will be doing next. Let's head to the documentation. Okay, so now we are good to deploy Cabana. Again, Cabana, we are using the API version Cabana from elastic.co version 1. Kind is Cabana, name is Quickstart, version 7.5.2, count is 1, and this one, Elasticsearch reference, tells this Cabana deployment to find the Elasticsearch. So Cabana needs to talk to the Elasticsearch to be able to query the data that's stored in the Elasticsearch. So that's what we are doing here. Okay, let's copy that and paste it here. Kubectl get all, and now you can see container is getting created and Kibana is of type deployment. Okay, watch kubectl get all, containers getting created. It's gonna take a minute or two. I'm gonna pause the video and come back when it's ready. Alright, so the Cabana part is now running fine. So now we need to access the Cabana. There are a few ways to access it. If you've got MetalLB deployed, you can set it as a load balancer type. Or if you don't have MetalLB, you can configure the service to be node port. Or you can just, if you're just learning it and if you don't have, you should be able to use node port. But if you want to do something quick, you can use port forwarding. Okay, let's see. kubectl get all. Okay, everything is running fine. So that's the service we will be accessing. First, let's try and access it using the port forwarding method. So again, we'll be using the same user elastic and same password, echo $password. We still have the password in the variable. Copy the password, and now we are going to port forward the Cabana service. kubectl port forward service Quickstart KB HTTP, and the port is 5601. You can see the port number here. Okay, and now we should be able to access it from our browser. So let's do that. Localhost :5601 advanced proceed, and now Cabana is loading, and we should be able to use the elastic user elastic, and the password is the one we copied. Login. Okay, so Cabana dashboard is loading now. Cool. Okay, so that's our sample dashboard. Okay, explore on my own. If we want to try something, let's try a sample data, for example. Sample e-commerce orders, sample flight data, sample web logs. Let's add this one. Okay. So this is port forwarding, and then next we will see how to do it using node port, and then finally using the MetalLB. Okay, view data, dashboard. Okay, so that's the sample data we used. The graphs are looking fine. Okay, I'm gonna log out from Cabana. Okay, close that, and I'm gonna stop port forwarding. kubectl get all. So now let's see how to access it using node port service. kubectl edit service Quickstart KB HTTP. I'm just editing this Cabana service, and I'm going to change the cluster service type from cluster IP to node port, and also I'm going to add an option to say node port is 32323. Otherwise it's going to assign you a random port. But anyways, kubectl get all, and now we can see the Cabana service is of type node port, and it's listening on 32323. And now we should be able to access this Cabana from any of our worker nodes. kubectl get nodes -o wide. kubectl get nodes -o wide. Okay, so the IP address of my nodes are these ones, so I can access it from any of the worker nodes. Actually, I also updated my etc hosts file, so I can access it using the name kworker1 or kworker2. Okay, let's see. kworker1 :32323. It's not working because we need to use HTTPS. Did I use no HTTPS : okay, it's loading the dashboard now. Advanced. This is warning because it's using self-signed certificate. Elastic password, I believe it's still in my clipboard. Okay, yeah, that's the right password. It's loading the dashboard. So that's using the node port service. We can look at the dashboard, canvas, maps. Let's look at the canvas at this time. And then next time we will do it using the Metal LB. Okay, revenue tracking. Alright, so all looks good. Let's wait for the things to load. Okay, let's log out. And now finally we will do it using the load balancer. kubectl get all. Let's change this. kubectl edit service. And I'm going to delete the node port. And I'm going to change the type from node port to load balancer. If you've deployed your if you're using your Kubernetes cluster in cloud using GKE or AKS, you don't have to deploy Metal LB. They automatically provision you a load balancer when you deploy a service of type load balancer. Because my cluster is on the local host here, not on any cloud, I've already deployed Metal LB. Okay, so that's it. I'm gonna save it, and if I do kubectl get all, and that's of type load balancer, and I can access it using this IP address and on port 5601. Okay, I'm gonna copy that IP address, or if you want, you can update your host file. Okay, and paste that IP. Let's call it logserver.example.com and go to the browser. So now https://logserver.example.com:5601. Okay, advanced Kibana dashboard is loading. Cool. Elastic and echo $password. Copy the password, paste it, login. Okay, cool. So that's Kibana dashboard and kubectl. I just want to show you one other thing. kubectl get Kibana. We have that Kibana is healthy. Elasticsearch is healthy. If you want to see everything in one command, you can use kubectl get elastic. That's it, and it will show you all the custom resources that Elastic operator manages, like Elasticsearch, Kibana, and if you have deployed APM server, then it will be listed here. So at the moment you can see the number of nodes, what version we are running, what's the state, whether it's ready, whether it's healthy or not. Okay. Alright, cool. Let's log out. Okay, what else? Let's see how to delete it. So far we have seen deploying the Elastic operator, deploying the custom resource definitions, deploying Elasticsearch, deploying Kibana, and then trying to access it, everything. So that's this video. In the next video we will look at FileBeat. It will be deployed as a daemon set, and a FileBeat pod will be running on every single worker node, and it will be collecting the logs of all the pods, all the containers running on those worker nodes. Will be sending it to Elasticsearch, and we will be able to look at from Cabana. So it will be a bit involved. I thought of putting everything in a single video, but that one is a bit involved because of the self-signed certificates. You need to do some jiggery pokery thing to get it working, so which will be covered in the next video. Okay, so now let's try and delete this. kubectl get elastic, kubectl delete Kibana, and the name is Quickstart. kubectl delete elastic search Quickstart. kubectl get all. Okay, so those are getting terminated. kubectl get elastic, no resource found. Okay, cool. I think that's all I wanted to show you in this video. If you've got any questions, please let me know in the comments. I'll be happy to help you. If you haven't already subscribed, please subscribe to my channel. So this Kubernetes series is an ongoing series. I'll be uploading videos on Mondays every week. And if you've got any questions, let me know. And thanks for your time watching this video. I will see you all in my next video. Bye-bye.